Here we have a question of group. So that the set G elements are 1 minus 1 I minus I. Fourth roots of unity is an abelian group of order 4 with respect to the multiplication operation. So first at all we form the composition table for the given set G. So the composition table for G. For G. 1 minus 1 I minus I. See how form composition table. 1 minus 1 I minus I. 1 minus 1 I minus I. Multiple this by 1, we get 1 minus 1 I minus I. When we multiply this by this minus 1, then we get minus 1, 1 minus I and I. When multiplied by this I, then I minus I. Since we know that I square equal to minus 1. So this I when multiplied with this, then we get I square. So here will be minus 1. And this becomes minus I square. So I square is minus 1. Minus 1 and minus become 1. So here will be 1. Similarly, when this all elements of this multiply by minus I, then we get minus I, 1 and minus 1. This is complete composition table of given set G. Now B. Examine the all conditions of a group to be an abelian group. So first is closure property. First one, closure properties, or can say closure law. Closure properties. Since here all the elements of composition table are element of, since all the elements of composition table are elements of G, so that G is closed. G is closed under multiplication operation. Under multiplication. Now associativity. Second, associativity. The elements of G, since the elements of G are complex numbers. Complex numbers. And we know that complex numbers are always complex numbers are always associative under multiplication operation. So G is associative. So G is associative. Now, third property, existence of identity. Existence of identity Here it can be easily see that the identity of G is 1. How? When we multiply all elements of G by 1, then we get same element. So 1 is the identity element of G. It is clear from composition table. Element 1 is an identity element. Of G. So identity exists in G. Now, existence of inverse. Existence of inverse since identity 1 is at close, the identity 1 is at crossing of 1 of in numeric form 1 and 1 as and -1 and -1 and -i and I. When we multiply 1 with 1, we get identity. -1 multiply by -1, easily see that as -1 into -1 get 1, I get 1, 1 into 1 get 1. So this -1 is the inverse of 1 and I is the inverse of -i, inverse element of -i. So inverse property holds. Here existence of inverse is hold. Existence of inverse satisfied. Now the last one is commutative property to be commute group. Commutativity. For commutativity, see that each row of table coincides with the correspondence column. Since each row of the table coincide with corresponding column. So it follows multiplication in G is commutative. It implies G is commutative or commutative under multiplication. Thank you. Here the all axioms to be abelian groups are satisfied for given set G. So here G satisfies all axioms of abelian group. Hence G is a abelian group. Thank you very much. This is complete solution of question. Thanks a lot.